Vidya Academy Science Classes by Ganesh Habbar. Today's topic is Class 10 Physics, Chapter number 12, Electricity, Part 7, Electrical Power. Now here we are going to discuss how electric power is measured. So we already know from our earlier classes, power is nothing but the rate of doing work. That means the rate at which the work is done. So that is nothing but we know that work is nothing but it is a form of energy. That is why I can also write, in other words, I can write it as rate of consumption of energy. What is the meaning of rate? The rate means something divided by time. Rate of anything, if I write, rate means rate of energy consumption, which can be written as energy divided by time. That means rate at which the energy is consumed. What is the meaning of range? So we know from energy range or rate at which the energy is consumed, that is E by T. I can write E by T is nothing but the how fast that energy is consumed by any object, that we can write as the rate of energy consumed. So we know the formula for energy from Joule's law of heating. It actually gives the heat energy, but we know heat is a form of energy. That is why both are one and the same. So we know from Joule's law of heating, energy consumed is equal to I square RT. Now from this particular formula, how to obtain power? Hence, power is equal to rate of consumption of energy. Power is equal to energy divided by time. That is, from this particular formula, the rate of energy is equal to E by T. I can write rate of consumption of energy. That is nothing but power, which is equal to energy consumed divided by the time. That means power, I can write it as I square RT. In this particular equation, if I write it like this, energy is nothing but from Joule's law of heating, it is I square R into T divided by time. Time means T. So time gets cancelled. At that time, I will end up getting the formula I square R. That is power P is equal to I square R. From this formula, again I can write from Ohm's law. What we have from Ohm's law? From Ohm's law, we have power, the potential difference V is equal to I into R. That is, potential difference V is equal to I into R. So substitute this here. This can also be written as I into R, I square R can be written as I into IR. So I into IR is nothing but V. So V, this is nothing but V. So V into I. So power P is equal to, I can write V is equal to IR, I square R, IR. So I can write this thing is nothing but V. So I can write V into I. So V into I. Next thing, again substituting the value of I from Ohm's law. From here, if I write I is equal to, what is the formula of I here? It is V by R. I is equal to V by R in this particular formula. At that time, what I will end up getting, so that is nothing but P is equal to V square by R. So it is V, and in the place of I have to write V by R. So V into V by R, that is nothing but V square by R. That is how to obtain the formula for power. The three particular formulas for power are very important as far as problem solving is concerned. Which are the three formulas then? These three particular formulas. These are the three formulas for power which are very important. One is power P is equal to I square R. One more is power P equal to V into I. One more is power P equal to V square by R. And what is the SI unit of power? SI unit of power can be written as is watt. So we represent SI unit of power as, or power is equal to V square by R. That is nothing but is watt. We call it as watt or joules per second. It is nothing but energy by time. Is it not? Rate of consumption of energy. But what is the SI unit of energy? That is joules. And what is the SI unit of time? That is second. That is nothing but joules per second. That joules per second itself is called as watt. That is a SI unit of electrical power. Next topic is how to represent the SI unit of electric power, or I think I can also say how to represent 1 watt or definition of 1 watt. So 1 watt. So what is the formula for electrical power? Power is given by power P is equal to, from this particular formula, power P is equal to V into I. So when will be this power P will be 1 watt? When it will be 1? So it is 1 when power equal to 1, power will be 1 when V will be 1 and I will be 1. So what I can write? Power will be equal to 1 watt when V equal to 1 volt. That is, the potential difference is equal to 1 volt and the current is equal to 1 ampere. Then how to define? They may ask you, define 1 watt. So that is an important question. Many times it is asked in your board exams. So how to define 1 watt is, definition of 1 watt is therefore power consumed by a source is said to be 1 watt when 1 ampere of current is flowing through a circuit when it is operated at a potential difference of 1 volt. That is the definition of 1 watt, or from this particular formula that is obtained from P is equal to V into I. So when will be this P equal to 1 watt? When it will be equal to 1 watt when V will be equal to 1 volt and I will be equal to 1 ampere. What is the meaning of that? That means if there is some device, this is some device, it is connected to a circuit through a battery and it is maintained at a potential difference V equal to 1 volt, and if 1 ampere of current is flowing through this particular circuit, then the power consumed by this device is said to be 1 watt. That is the meaning of this particular definition. Therefore, how to define 1 watt? 1 watt is the power consumed when 1 ampere of current is flowing through the circuit when it is operated at a potential difference of 1 volt. Then what is the commercial unit of electrical energy? Next thing is about commercial unit of electrical energy. That is also called as 1 kWh or 1 unit. Say for example, in your home, the meter reader will read the readings in the electrical meter in each month, right? So what is that in that reading? It will be written. Now it is free of cost, it's of no use, that's why now, but still the number of units consumed they will read. So what is that number of units consumed, what we call that unit as, or else when that particular number will be 1 unit. Say for example, your present reading, so present reading in your meter is 1128 something. It is written as 1128 kWh. Now when does it will become 1129? Do you know that? So that itself is, what is the difference? There is nothing but 1 unit. When we say that we have consumed an electrical energy which is equal to 1 unit, that is nothing but, it is the same thing is also called as 1 kWh, or what is the definition of 1 kWh, or the meaning of 1 kWh is 1 kilowatt hour. What is the meaning of this 1 kilowatt hour? That 1 kilo means 1000, that means 1000 watt hour. 1000 watt hour is equal to 1 kWh or equal to 1 unit. That means what? You have to use a power of 1000 watts for how much time? For 1 hour. Then your meter reading will be from 1128 to 1129. For example, I am telling this values. Present reading, if it is 1128, if you use any device of which consumes 1000 watts of electrical power, then the after 1 hour, if you use it for 1 hour, then after 1 hour the reading will be 1129 in your meter. That is the meaning. That means you might have seen while purchasing a bulb or purchasing any electrical goods, it will be written what is the power consumed by that particular device. If I use a bulb, say for example the olden bulbs such as incandescent bulb, it will be written 60 watt, 40 watt, 100 watt, like that. But nowadays the LED bulb has come, so it will be written, there won't be this much number, 60 watt, 40 watt, 100 watt, etc. will not be there in this number, in these bulbs. Why? Because it consumes less power. Nowadays whatever the bulbs which are available in the market, they consume, that is the LED bulbs, they consume only 9 watt or 6 watt or 12 watt, like that. Very much less compared to the olden incandescent bulbs which use tungsten. I hope you know that those bulbs. Nowadays we use all these bulbs. That is why the power consumption gets reduced if you use the LED bulbs of different wattage. That wattage is nothing but power consumed. That means if you use 9 watt bulb or and 6 watt bulb differently in different rooms, then this 9 watt will give more light when compared to 6 watt, and 12 watt bulbs will give you much more light when compared to 9 and 6, like that. That is the meaning of the commercial unit of electrical power. Now how to define the commercial unit of electrical power? So remember, this particular commercial unit of, that is 1 kWh or 1 unit, these are the units or SI units of commercial units of electrical energy. Remember, these are not the powers. Watt is a unit of power, or when I multiply it by time, that is watt hour. Watt hour will give you the unit of energy. Remember this. So don't think that 1 unit or 1 kWh, these are the units of power. These are not the units of power. These are the units of the energy consumed by device. Only when, if I write kW, that is kilowatt, that is actually the unit of what? Kilowatt. Kilowatt means 1000 watts. It is a unit of power. But remember, when I multiply it by time, kilowatt hour, these are the units of electrical energy. Now they may ask you, define 1 unit. How to define 1 unit? So definition of 1 unit is, how to define 1 unit? So it is the energy consumed. So definition of 1 unit is, it is the electrical energy consumed by a device which consumes a power of 1000 watts when it is operated for 1 hour. There is a device whose power is 1000 watts. If that particular instrument is used for 1 hour, then the electrical energy, commercial unit of electrical energy is said to be 1 unit or 1 kWh. Remember, 1 kWh and 1 unit are one and the same. Now we shall solve certain problems related to this particular chapter, that is electrical power, that is related to this particular concept which we have discussed just now. That is, the problem is problem number 1. An electric iron of resistance 20 ohm takes a current of 5 amps. So takes a current of 5 amps. Calculate the heat developed in 30 seconds. So this is a problem which is of the Joule's law of heating. What is the Joule's law of heating? We shall solve this problem. What is from Joule's law of heating? From Joule's law of heating, we have before solving any problem, we have to write down the given values. So what are the given values here? So given values are an electric iron of resistance 20 ohm, that is R is given, R equal to 20 ohms, and takes a current of 5 amps. Current means represented by the letter I, which is equal to 5 amps. Calculate the heat developed in 30 seconds. That means T is equal to 30 seconds. What we need to find out? The heat generated, which is equal to H. So that we need to calculate. So from Joule's law of heating, we have what? That is H is equal to heat energy liberated, which is equal to I square RT. This is the formula of Joule's law of heating. So substitute all these values. We have all I as well as R as well as time. So you can calculate H easily. That is I is nothing but 5 square into R is given, that is 20, into T is nothing but 30. How to calculate this? It is 25 into 20 into 300. That is nothing but 25 into 20, that is 500. 500 into 30, which is equal to 5 3 are 15, 0 0 0. That much. It is nothing but the heat energy. So the unit should be that much joules, 15,000 joules, or I can write 15 kilojoules. This can also be written as 15 kilojoules. Kilo means 10 to the power 3 or 1000. So 15,000, 15 into 1000 is 15,000. So it is 15 joules. So I can write the energy or the heat developed by that particular instrument in 30 seconds is equal to 15 kilojoules. We shall discuss the next problem, that is an electric motor takes 5 amps from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. First, before solving the problem, we have to write the given values. So what are the given values? Given an electric motor takes 5 amps. That means the current is given. I is equal to 5 amps from a 220 volt source. What is 220 volt? That means voltage is given or the potential difference is given, that is equal to 220 volt. Determine the power of the motor and the energy consumed in 2 hours. That means the time is also given, that is 2 hours, and also they have asked us to find out the energy power as well as the energy, which is equal to how much. We shall discuss about the power first. That is, power is equal to, what is the formula for power? Power is equal to V into I, which is equal to V is the potential difference 220 into the I is equal to 5, which is equal to 1100. What is the unit? 1100 watts. Or in terms of kilowatts, if I want to write, that is 1.1 kilowatts. 1.1 kilowatts. That is the answer for the power. In terms of kilowatts, if I write, that is power is equal to 1.1 kilowatts. Next, the energy is asked. How to find out the energy? Energy is equal to, what is the formula for energy? Energy is equal to P into T, which is equal to P is nothing but 1.1 kilowatt into 2 hours, which is equal to 2.2. The answer will be in 2.2 kilowatt hour. That is nothing but 2.2 units. But in this particular problem, they have not mentioned or they have not specified find out the energy in units or in joules. Actually, joules is also a unit of energy, right? We shall find out the unit of this, not the unit. We shall discuss energy. We shall find out the energy also in terms of joules. What is the conversion factor? That I forgot to tell you while discussing the theory. That is the conversion factor for converting kWh into joules. 1 kWh equal to how many joules? Both are actually energies. So remember 1 kWh or 1 kWh or 1 unit is equal to 3.6 into 10 to the power 6 joules. So that is the conversion factor, very important to convert it from kWh to unit, kWh to joules. So in order to convert this here, in order to find out the answer in terms of joules, what we need to do? 2.2 into 3.6. We have to multiply by 3.6 into 10 to the power 6. So end up getting, I will use the calculator to find out this. The calculator says the 2.2 into 3.6, which is equal to 7.92. So the answer is 7.92 into 10 to the power 6 joules. That's it. Or else also I can say that it is 10 to the power 6 is always mega joules. 7.92 mega joules of energy, or 7.92 into 10 to the power of 6 joules of energy is consumed by that particular electric motor if it is used for 2 hours. In this particular chapter, whatever the things which I have discussed in the last part of this particular chapter are: first thing, electrical power. Next we have discussed about SI unit of electrical power. Next we have discussed about the definition of 1 watt. Next about the commercial unit of electrical energy. And the last concept which we have discussed is the definition of 1 kilowatt hour or 1 unit, that is the commercial unit of electrical power, its definition. And one more thing we have discussed is the conversion of kWh into joules. So by this we have come to the end of the electricity chapter. So any feedbacks related to this particular chapter are most welcome. So, and if you have any doubts related to the concepts which you have discussed, which we have discussed in this particular chapter, you can comment it in the comment box. So I request all of you to subscribe, share and like, as well as watch this YouTube channel as much as possible. Thank you.